Good afternoon. Thank you very much for taking the time to join us today, and a warm welcome to Highcon Systems head office, where the team and I have the pleasure of presenting our latest technology serving all sectors from folding carton, corrugated and commercial print, such as the solution that you see behind me today. My name is Russell Weller. I'm one of the business managers here at Highcon. Joining me today is Arnon Grach, who's one of our product marketing specialists, and also Sam Ward, who is our customer success manager. Those of you that are not familiar with Highcon Systems, we're a global developer and manufacturer of high-speed digital converting systems. And as mentioned, the system that you can see behind me today and the one that we will use for this live presentation. So Highcon Systems, we've been developing for many, many years and serving customers all around the world. Now, if we just look at some of the trends that we see and we witness within inside of our industry, and I just focus on one of them, that's digitization. And we've seen it for decades, moving upstream into the pre-press, where customers have been enjoying receiving files to the print faster than ever before. We see it in the print hall, where customers are enjoying mixing digital and conventional for efficiency gains and the best possible way of producing that job. And that's no different today with our customers that use our technology. So customers that have invested and utilizing a Highcon system are gaining all of those digital benefits within inside of their digital processes. Now, this is customers that are in the e-commerce, producing web to pack work, where we see very, very, very high demands on lead times, that we have to get the jobs much quicker to the customer. We see this in the folding carton market, where maybe they've got short run jobs that are taking much longer to set up than actually running the jobs. We can move those jobs onto a Highcon system, bring efficiency gains, margin gains for that particular type of work, but also bring capacity gains onto that existing analog machine. And we see it across corrugated packaging, corrugated display, where we even see customers mixing techniques of the same job. That could be an analog, a flatbed cutter, but also utilizing the production benefits of digital and the production benefits of a Highcon system. Today, the team will be presenting two jobs for you. We will kick off, first of all, with a folding carton job. That job has already been set up. So we'll talk you through the machine and we'll get the machine running. Really want to show the productivity gains and benefits from a Highcon system. What we will then do is we will then switch to a corrugated job, and we will show you that job being set up from scratch. Digital has many, many benefits, but that rapid setup, that rapid job changeover is what we really want to show you today. Just before I hand over to the team, just want to touch on a few points. We will be recording this session today. So those of you that miss any of it or want to share it internally with colleagues, we will ensure in the coming days that we get that copy of the recording out to you with other information. And you will also notice that you're on mute. There's a lot of people joining us today. We want to limit the background noise as much as possible so you can hear what the team has to say. But we do welcome questions. So at the bottom of the screen, you will see a chat window. Please, we encourage asking questions throughout the presentation, and we'll ensure we have enough time at the end to answer as many of those questions as we possibly can. So for now, that's enough from me. I'd like to hand you over to the presentation team and welcome Arnon.
Thank you, Russell. Hi, everyone, and thank you for joining. We're standing right next to the Highcon Beam 2 digital cutting and creasing system. This system runs up to 5,000 sheets per hour. I think we'll start with the first job, the folding carton job. This is a 320 GSM FBB. It's a ganged layout, offset, printed in offset. Highcon systems are print agnostic, so it doesn't matter what print technology or inks, we can run them all. So let's start looking at the system. We'll start with the feeder. This is a standard pallet base, and we've designed and developed this feeder for easy and quick setup for any substrate thickness ranging from 200 microns up to 2 millimeters E-flute. Sheets move on for an initial mechanical alignment in this area. And then we have an optical registration detecting the sheet, detecting the print, in order to have a correct, good registration for even for print-to-print variations. We have the option to have, like we're running right now, cameras that are detecting marks on the top, and we can also run it from the bottom as corrugated are run with the print side down. Moving on, the sheets go into the Highcon dart system. This is our creasing system. What you see here are the crease lines on the top drum, and while the sheets are moving between the drums, the crease lines are pressed onto the sheet and creating the crease lines for the sheet. Okay, let's see what we have here. Okay, so we see the job has stopped. Sam, can we
Yeah, sure.
take a look
just
at
checking the
what's
sheet.
going on?
Sure.
So this is, as I mentioned, this is a gang layout with 4 different products. When you look at production of long runs, you typically see each of these products run separately through the production line. But when it comes to short to medium run lengths, using this same production approach doesn't make sense because it's much less profitable, if at all. Think about job orders that are only thousands of sheets. For each of these 4 jobs, you would have to have a full set of plates that's full make-readies and all the waste that goes with it. So ganging these 4 jobs into one layout obviously reduces a lot of the press costs and time. And this specific layout, think of it, 4 jobs, we could eliminate 3 full press runs. Of course, you can print this digitally if you have the equipment, but it doesn't end there. What about the next step? Okay, the next step, the cutting and creasing. So the whole ganging deal, it doesn't make much sense if you don't have digital cutting and creasing. And the fact is that you can't really enjoy the benefits of cost savings and high efficiencies that go along with a gang layout. Because if you take this layout, for example, for a conventional die cutter, you'd probably be using a one-off die for a relatively short run length. And this will dramatically increase the cost per sheet and squeeze your margins. So by adding a Highcon system for these types of jobs, you can actually effectively raise the throughput of the shift while reducing cost of the plates, the print make readies, and the tooling. And it doesn't end here. So by not placing these types of jobs on your conventional machines, you can maintain healthy production efficiencies for your die cutters. And all of this is enabled by Highcon digital manufacturing and workflow. So let's take a look at the quality of this production. As you can see, Sam here has been folding and gluing, and maybe the camera can take a zoom in, see the quality, the accuracy of the creasing and the cutting. We have customers worldwide producing their products, selling to their customers, and using Highcon systems for converting for packaging making. Okay, so what do you say, Sam?
Yeah, so I can maybe I'm mid-run, so I can take the stack up, and then I can begin to show you the stripping if that's what you'd like to do, or we can move on to the next job.
Okay, we can move on to the next job. We'll
Okay.
start the setup from
Sure.
scratch.
No problem.
During this phase, we'll also talk about the laser cutting that does not need any kind of tooling, of course. And of course, the stripping unit. We have an integrated stripping unit that cleans off all the excess debris, the small particles, and there's no tooling required for this. So Sam is starting to set up a job from scratch. The next job is an E-flute job. And the first thing Sam will be doing is unmounting the foil of the previous job. What we call foil, this is a clear PET where the crease rules are attached to them. Sorry. The way we apply these rules, the way we use them, we are extruding photopolymer resin, which after the writing of the crease rules is cured by UV. This material, this polymer is designed and manufactured, developed and manufactured in-house. So we can really control all the mechanical properties and the quality of the material and the extrusion and the adhesion onto the PET foil. And a great benefit that we have with this technology is that we can optimize the crease heights according to the substrate properties, the substrate thickness, and optimizing, changing the heights of these crease rules to achieve optimal folding force is done by software. It's not done, we are not changing any kind of hardware. There's no tooling involved in this. It's just by software. And for this setup, we're able to achieve optimal, the best folding force for these products to go through the folder and gluer. Place this over here. So as I mentioned, we have the PET foil. We have a writing mechanism that extrudes the polymer onto the top drum, and we have a special counter on the bottom that acts as a counter when the sheets are pressed between the two drums. So this concludes the part of the changeover, removing the previous foil. Sam has just mounted a new foil. Then we will go to the user interface. Okay, he loaded the file, or he will be loading the file. And the system recognizes, understands the file, either PDF or DXF, and we'll start writing the creasing rules. A process that takes, depending on the layout, the amount of rules can take somewhere between 4 to 7, 8 minutes. But let's take a closer look at this next process. As you can see, the drum is homing. We have this protective window up generally. When we'll be in the middle of the writing just before the curing, we'll drop this window down because this the polymer will go through a UV curing. And let's take a close look at our technology of extruding the crease lines. So the material is extruded. Currently, it's in a state of something with a viscosity similar to toothpaste. And once it's cured, we get a very durable crease rules. Each foil can go up to 50,000 impressions. And each of this foil is reusable up to 5 times. So if I unmounted a foil, I can save it on the side. And if I have a recurring job, I can mount this and run this job again, saving the time that we have for preparing the crease rules. So while this is writing, Sam is replacing the pallets. Let's have a look at some of our customers' work. Our customers are ranging from folding carton applications, corrugated packaging, corrugated displays, and their customers, some of them are large brands like Nestle, Mondelez, Coca-Cola. So it's very clear that we have our products being sold on the shelf. Let's take an example. Let's look at something that some of our customers are doing. Their business in creating displays, and they're utilizing the Highcon systems for cutting the shelves and for the components. And they're very satisfied with the Highcon, of course, because it costs them a lot less. If you think about the cost of the dies, conventional dies to create this, and the setup time, and especially the stripping tools to get out all of these intricate pieces out, this is a very costly production to be done conventionally. But that's not only it. So we have very accurate laser cutting, but we also have non-crush technology. So unlike conventional die cutters, which have an overall crush, and they also have, you will get the output, you'll have crush on the areas of the knives, we do not crush the board. So there's enhanced visibility for a display, and it's also improving the sturdiness of the display. So we have a peer review publication by a leading university, European university, that compared the box strength of the same corrugated board, one time done conventionally on a flatbed die cutter, and then on the Highcon. And in this comparison, the conclusion was that boxes produced on the Highcon are stronger than those who are produced on a flatbed. So what this means is that you can basically have a stronger box, and you can also lower the grade of the material, use less material, and achieve the same durability and box strength. So this, of course, this means a lot in terms of sustainability. It's lightweighting, it's using less waste, and at the end of the day, it costs also a little bit less to have these corrugated boxes in this kind of material. We can go on. Let's take an example of one of our customers who was producing folding carton confectionery. We're very much moving into sustainable packaging, recyclable packaging, and this is an example of a monomaterial packaging, and the idea is to replace the plastic tray with a paper tray, which was also cut on a Highcon system. Okay, of course, we have the common regular packaging. If you take an example of this vitamin box, and you think about the die, the complexity of the die to put all of these applications in one layout, and the time it takes to set up this production on a conventional time. So there are huge savings when we are using the Highcon for this. Let's take another look. Premium application. This is a Kit Kat box sold as a promotional product on the internet, and it's interesting because the box is made conventionally, and the sleeve with the added value was produced on the Highcon. This is a box that contains 8 bars of Kit Kats, and it was sold on the internet for over 16 pounds. Another huge, okay, I'd also like to talk about interesting boxes. This is real products. We actually picked up these bottles, this one and this one over here, in a airport duty free in the Czech Republic. Yeah, another huge advantage is having the laser to use for the unboxing. Okay, we can optimize the laser and have it really accurate for whatever substrate type, for whatever thickness, and give the maximum experience of the unboxing experience, and tamper against tampering. All of these, you can see these examples of fine cutting. And when we're introducing a new product, so unlike a conventional die, which you would probably have some iterations, fine-tuning the knife and selecting the correct knife for the substrate, we can do this in a matter of 2 minutes or less. Yeah, I like this example. One of our customers is reducing costs on the print. So he's actually adding value, adding the visual value to the package, but he's cutting costs on the print and still getting a corrugated brown box to have a nice visibility on the shelves. So why don't we go back, check with Sam, see how he's progressing. Good.
Hi, guys.
Sam, my friend, can you please tell us?
Yeah, sure. So I've written the dart. So the material we got on now is an E flute with a litho lamination on top. So I've had to write the crease. Obviously, it's a wider crease rather than the folding carton crease, similar to the conventional whirl with creasing matrix. As you can see, it's been creased from the reverse. This gives us a superior crease. And what I'm looking for, as you can see here, I've put a series of partial cuts on top of that. And why I'm doing this is I want to match up the partial cuts with the creases. This is so I can get the extreme register what I'm after. And I'm also checking for the cutting. I'm checking for any variations what might come from the print. And checking the stripping. As you can see, the stripping is looking great. So we have a perforation on here as well. So perforations in the conventional world can be quite tricky because you won't be able to get your pressures right. You don't know how it's going to tear and fold. But the beauty of a Highcon is you can rip and tear, and you can govern this on a percentage basis. So you have all the tools, or the operator does have all the tools available to him to actually dictate the quality. And as you can see, we're in register. I would also fold it as well, make sure everything's folding square. And I'll glue it as well.
So this was the first sheet of a setup sheet.
This was the number one
extruded,
sheet,
right?
yes, Arno. So number one sheet, I'll run one more sheet without the, I'll have the machine running. But first thing, I'd like to check that when it went through the machine, it looked like we could do with a few more nicks. So we'll need to go back to the UI and put a few more nicks onto the file. But then, so far so good. The folding is nice and square. And that's what we're after. So I'd be happy to run that.
So are you planning to run a second setup sheet?
Yes, exactly. But obviously, before that, I want to have a look at the nicks because I wasn't quite happy with that. The operator is really clever how it works because the operators before in the conventional world, they was really dictated on the nicks because if they put a nick in a certain position, let's say if they put two nicks, just one moment. If they put two nicks, sorry, just need to stop the machine. So if they put two nicks, just one moment, Tal. So if I want to put two nicks in here in the conventional world and the customer doesn't want that, that's a small nightmare for a conventional operator because he has to take out this knife, take all the rubbers off it, and then maybe if there's a curve on there, you might have to rebend the rule. Where I've got the complete ability to click them, remove them. As simple as that. I have the ability to change the size of the nicks as much as I want to, even to 0.1 nicks. It is really flexible. So like I said, I wanted to add a few more nicks just to keep it more stable for the job. Save and close, and that will automatically go onto the file, and then I'll be able to run. But I need to take off my partial cuts because I've been trying to marry up the crease and the cut together. And then I'll go into production mode. I'll run a few sheets. I'll check for any variations or creasing, cracking, but I'm expecting this to run really well. So as I said before, I'll be looking for everything what I can impact as an operator.
Why don't we take a look at the laser chamber as it's cutting? What we see here, this is our laser chamber. We have 3 lasers cutting simultaneously, each laser with the 1 kilowatt of power. And if you move on to the stripping station, you can see this integrated stripping station that requires no tooling and cleans the sheet off with all the excess particles and debris. So Sam, you've run a few production sheets right now and you're validating the quality of the job?
Exactly. So just like the conventional world, I can take a few out and blank them by hand just to make sure it's working as it should. Because if we go to all the other companies who do blanking and stripping, they don't break things out by 1s and 2s. They break things out in big handfuls. And as you can see, it's breaking out just fine. Thank you, Arnon.
It's really easy to break.
Exactly. And there we go. Fully stripped. Again, I'll give it a fold. Make sure it's folding nice and square, which it is. And on, I'll probably begin to run.
So these are actually could be called first production sheets.
Yes, these will be my setup sheets following into a production sheet.
So
job.
I wasn't looking at the time when you started the recipe, the job setup, but I'm pretty sure it was just under 15 minutes, if not less.
Yes.
So this is 15 minutes for a job setup from scratch for an E-flute. And remember that there are no lead times for tooling. We didn't wait for tools. So ideal for rapid production, rush jobs. We have customers receiving orders in the morning and delivering them in the evening. So this is the kind of things that Highcon systems can solve. We have a lot of benefits, including what Russell described, increasing efficiencies by taking the correct job, the correct orders to our system, not decreasing production efficiencies of the conventional die cutters. There's a business out there. There's a business out there for short to medium run sizes, fast deliveries, where you can also take premium and you can also keep your customers satisfied with the quality produced by Highcon. So the system is running production right now, the second production. I think we're done with this part and then we can pass it back to Russell.
First of all, a big thank you to Anon and to Sam. We wanted to set them the challenge of doing a live presentation. It's obviously very easy to do it with PowerPoint or with videos, but it's really important to us to show the power of digital, not just from a production capability that you saw today, but that rapid changeover. So going from a folding carton job to a corrugated job seamlessly and rapidly is very, very, very important, but beneficial from such as a digital solution. So thank you guys for that. Now, I appreciate that you've seen a lot today. Anon and Sam went through a lot. We tried to keep it as interactive as possible. But just to recap, with a Highcon system, you can get all of the digital benefits with a mechanical crease. That's really important for all of those production steps. Maybe the job is going on to a folder gluer after the Highcon device. That is not a problem for jobs that have been finished with our technology. No need for a die. If you've got margin challenges or short run, we don't need the cost of the die. We can make the job much cheaper, much more efficient. And that also leads into the lead time benefits. We don't have to wait 24, 48 hours for a die to be produced. We can start producing immediately. It comes off the back of a press, digital or conventional. And then there's sustainability. We can talk much more about sustainability. Arnon went into quite some detail. Again, a great question coming from somebody that's attending the event. But we do have a very, very, very sustainable solution here, again, for many, many benefits. So if there's interest, we've created lots of documentation and white papers. And one of the members of the team will be very happy to go into much more detail around the sustainability story messaging that we have with the solution. And the last thing I'd just like to say in terms of the benefits, we're not trying to replace analog with our solution. They can coexist and complement each other. Of course, we have customers that have an entirely digital setup in certain sectors, but there's lots of customers and print shops out there that still need, for long run purposes, as an example, to keep that analog technology. We're not looking to replace that. We're looking to bring benefits and efficiency gains at the right stage of that production process. So that could be short run work, very complicated to set up on an analog. We can move that work here. You saw Sam with a rapid setup, even quicker with the offline writing of our creasing technology. So it really is about having the right machine at the right moment of that production process that you have. And of course, there's many other benefits that we'd be happy to talk to as the weeks and months progress. So that really just leaves me to say thank you very much to the team. Thank you very much for your time today. I appreciate you've invested your time, so we do appreciate it. We will send out the recording as promised. One of the team will reach out to you as well. So if you have a local representative you know of, please reach out to them, but we will be in contact with you, or visit the website and you'll have contact details. And again, thank you very much for your time today. I hope you found that of interest, and I hope you enjoy the rest of the day. Thank you very much.